Hello and welcome to Maths with Jacob. This lesson will focus on miscellaneous computations with decimals. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. You will have an opportunity to subscribe to my channel at the end of the video. You are also invited to share this video with your friends. Thank you in anticipation. Scientific notation and approximation. In one of my earlier videos, I talked about significant figures. As far as scientific notation is concerned, we can round off an answer to a specific number of significant figures, depending on the desired level of accuracy. For example, write 4,790,200 in scientific notation correct to 1, 2, 3 and 4 significant figures. Now here is the first answer. That'll be 5 times 10 to the power of 6 correct to 1 significant figure. Now that is the least or the lowest level of approximation. That's not very accurate, but it is an approximation, and that's why the 5 here, that's only 1 significant figure. Because basically, this number here is 5 million, which is a rough approximation of this number here. Now, to 2 significant figures, we have 4.8 times 10 to the power of 6. So the 4 and the 8 are both significant. So this is a closer approximation to this number here, because this is 4,800,000. So you can see that the more significant figures we have, the better the approximation. Here we have 3 significant figures, 4.79 by 10 to the 6th. Because the 4, the 7 and 9 are all significant, so that's 3 significant figures. And here we have 4 significant figures. Now you remember in my earlier video, when we have a decimal point here, all zeros after the decimal point become significant, so that's why you have 4 significant figures. Decimal places. When we are given a decimal, sometimes we are asked to write it down to a specific number of decimal places. We must be careful to look at an additional digit in the example before writing down our final answer. Let's look at the examples on the next slide. Write 0.043061 correct to 4 decimal places. All that means is you have to have 4 digits after the decimal point. So you don't just take the first 4 here. You've got to look at the next digit here. See that? That's a 6. Now the rule I follow, if that's a 5 or above, I add 1 to this digit here. So that's why I've got 0.0431, because that's a 6. Therefore you add 1 here. That's closer, that's a better approximation. Now we're going to write the same decimal correct to 4 significant figures. Okay. Now, my earlier video says to you that zeros before a whole number, see this non-zero digit here, all of these zeros which are before this 4 are not significant. Now, let's look at the answer. 0.04306. Now, the 4 is significant because it's a non-zero digit. The 3 is significant. The 0 is significant because it is located between 2 non-zero digits. And the 6 is also significant. So that's why that is the answer. Now this remains as a 6 because the digit after it is a 1. Now if that digit there would say 6, 7 or 8, that would become a 7. But it's not, it's only a 1. That's why I've left that as a 6. Surds and parentheses. Express the square root of 3 squared plus 6 squared in the form a the square root of b, where a and b are integers. So here is the initial sum. 3 squared is 9, 6 squared is 36, 9 plus 36 is 45. Now 45 is 9 times 5. The square root of 9 is 3, so that's the 3 the square root of 5. That's in the form of a the square root of b, where the 3 and the 5 are integers. Now write the above correct to 2 decimal places. So the square root of 45, if we put that in our calculator, we get all these digits here, and it continues on forever. Now remember, when you go to correct to 2 decimal places, you have to look at the next digit. See how this digit is an 8? You increase the 0 to a 1. You go to the next digit. So the better approximation is 0.71, and that's 2 decimal places. Now here's a very tricky little sum to do with fractions. We want to find the exact value of this here. It looks a little bit complicated, and you can get a little bit overawed. This is a challenging calculation which needs to be approached systematically. And this is how we approach it systematically. Firstly, simplify the numerator. So the part on top, 3 on 4 plus 2 on 5. Now, I showed you in an earlier video how to do this. 20. See the 20 here? The reason I have 20 is the 4 and the 5 both divide into 20 evenly. 4 into 20 goes 5. 5 3s are 15. So see here we have 15 over 20. That's the same as 3 over 4. 5 into 20 goes 4. 4 2s are 8. The 8 over 20 is the same as 2 over 5. So what we have now, that 3 on 4 plus 2 on 5 is really 23 over 20, because 15 plus 8 is 23, so that is the numerator simplified. Now the denominator. Now this is a subtraction. Exactly the same principles apply. 5 and 2 both divide into 10. 5 into 10 goes twice, 2 4s are 8, 2 into 10 goes 5 times, 5 1s are 5, 8 minus 5 is 3, so that's 3 over 10. So basically our new sum is 23 over 10 divided by 3 over 10. An earlier video of mine taught you how to invert and multiply. So if you are dividing, if you have one fraction, and you are dividing it by another fraction, you turn the second fraction upside down and you multiply. So we do the cancelling. 10 into 10 goes once, 10 into 20 goes twice, 23 times 1 is 23, 2 3s are 6, so 23 over 6 is actually 3 5/6. So there we are. That answer there, we have found the exact value to this very challenging sum here. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle, cross-check. Oh, I think you can see that. That's quite straightforward, isn't it? I bet you got that one. Here are the answers to the quick quiz, and the video is at your disposal. If you found this video useful, please subscribe on the next slide. You will receive a notification when the next video is available. Please share with your friends. Hope to see you next lesson.